Hello students. So from the nitrogen, the next main compound is nitric acid students. Nitric acid formula is HNO3. So the main points about nitric acid, about like where do we can use nitric acid, like what is the use of the nitric acid, let us discuss first of all. So nitric acid is mainly used as an oxidizing agent students, and it is an acid. You already know the acidic property in many organic reactions or general reactions also. Acids are used as reagents, same nitric acid also used as a reagents, and mainly the salts which are produced from this nitric acids have very important significance, like potassium nitrate, magnesium nitrate, sodium nitrate. They act like explosives also, and ammonium nitrate, they can be like used as a fertilizers also. So altogether nitric acid is one of the important chemical to study. So in this video students, first of all, introduction. Nitric acid is also known as aqua fortis, means the meaning is strong water. Why? Because it's an acid. So we all know all these names, general names, common names are coming from the very olden days based on their use. So nitric acid is the only liquid that can dissolve silver metal. These exceptions, these main points definitely you have to remember. And the mixture of nitric acid also can dissolve the stable noble metal like gold also, that we'll discuss in the coming slides. So it is a its molecular formula is HNO3, nitric acid, and its molecular weight is 63 grams. Like hydrogen is 1 gram, nitrogen is 14 grams, oxygen 16, 3 into 16 which is 48. Altogether 63 grams is the gram molecular weight. So what are the other names? Other names are also very important. Like I said, where do they get all these names? For example, what is H2O? Water. Water is not a chemical name, it is a common general name. Its chemical name is dihydrogen monoxide or hydrogen hydroxide. Like that, every chemical, not every chemical, like the chemicals which are being used from very olden days have certain names, several names. So the other names of nitric acid is aqua fortis or spirit of nitre. Nitre means the famous chemical which is used as an explosive, like potassium nitrate or sodium nitrate. So where we can synthesize those explosives from this nitric acid. So it got its name. And saltpeter acid, saltpeter, same, saltpeter means nothing but nitrate salts, and hydrogen nitrate. So these are all the other names, but mainly commonly it is called as nitric acid. So occurrence, how it is available. So in the free state, nitric acid occurs in acidic rain. Like we discussed in the previous video students, the nitrogen dioxide gas which is into the atmosphere react with excess oxygen and the water vapor H2O, and it produces nitric acid. This nitric acid with combination with rain falls down as acid rain. So we can available nitric acid in the free state, in the sense like in the air it is available with rainwater, associated with rainwater, called acidic rain. And combined state means, we see this is also combined state only, but here combined state means students, mostly this nitrate, the nitrate part coming from nitric acid is available with certain salts like Indian saltpeter or chili saltpeter, which is sodium nitrate and potassium nitrate. So examples, look at chili saltpeter, sodium nitrate, and Bengal saltpeter, also called as Indian saltpeter, which is potassium nitrate. From there we can also synthesize nitric acid. So their combined state means it is available in their salt formation, right? So preparation of this nitric acid, how to synthesize nitric acid, laboratory preparation. First of all, we can synthesize nitric acid with ammonia students in the ratio of 1:7 or 1:8. So this ammonia, when reacts with excess of oxygen in the presence of platinum acts like a catalyst, it weakens the bonding in the reactant molecule. So we can expect nitrogen dioxide gas as well as H2. Look at the temperature, 1275 kilojoules per mole of energy is utilized here, and it is released here, and 4 NO2 molecule. And this nitrogen dioxide molecule students, it reacts with the remaining excess of oxygen and H2O, it synthesizes nitric acid. For example, here, look at here, nitric oxide, this is nitric oxide. So if there is any nitric oxide molecule, this react with oxygen and produces nitrogen dioxide. Altogether nitrogen dioxide, nitric acid in the presence of oxygen gas and H2O, it synthesizes a nitric acid, which is HNO3, and this acid formed is about 61% concentrated. That means already water is there, sir. You already know the concentrated acid mixed in water is like diluted, and concentration depends upon the relative amount of change in the difference of amounts. So here it is 61% concentrated nitric acid can be synthesized using ammonia mainly in the presence of oxygen. So here the intermediate products are nitric oxides and nitrogen dioxides. So next, physical properties of nitric acid. Nitric acid is a colorless, but it appears yellow in color due to its decomposition into nitrogen dioxide by sunlight. Not only yellow color, it also like slowly changes into brownish color also, yellow to brownish range of color, because mainly nitric acid over the long time it decomposed into nitrogen dioxide. It has its characteristic brown color. In the process you can expect the yellow color also. Nitric acid is soluble in water. Yes or no? Acids are soluble in water. That's why they can show acidic behavior. What is acidic behavior? They can release H plus ions. Acids can release H plus ions. Nitric acid formula is HNO3. HNO3 will release 1 H plus ion. So that is an acidic behavior. Nitric acid is hygroscopic in nature. Hygroscopic means the tendency to absorb the water molecules from the air. That is hygroscopic nature. So nitric acid is one of the acid which has this nature. Here, this is the main point to remember. Nitric acid is very corrosive and burns the skin. Like all acids, like all the strong acids, it can burn the skin. Why? Because of its corrosion. Like sulfuric acid, hydrochloric acid also has this corrosiveness. Strong acids are corrosive. So nitric acid is very soluble in water, like we discussed. Yes, it is very soluble in water. What is solubility? The ions will be, the opposite ions will attract with each other to the water molecule. That is the solubility. That is what dissolving is. Here nitric acid can release H plus ions in combination with water. So pure nitric acid boils at 87 degrees Celsius and freezes at minus 40 degrees Celsius, forming white crystal. So these are the temperatures of its melting point and boiling point to be remembered. Chemical properties of nitric acid, students. Nitric acid is a strong acid. You already know what is strong acid. If it has a capacity to release maximum H plus ions, its degree of dissociation is more than 30%. That makes it strong acid. So it is a strong acid and it turns blue litmus to red. That's a characteristic color change for all the acids. As no, blue litmus to red color. Nitric acid decomposes on standing to form the brown nitrogen dioxide gas, like we discussed in the previous slide. This is the reason why it becomes brownish over the time, though the fresh nitric acid is colorless. In general, nitric acid is colorless only. But slowly what happens, students? Nitric acid in the presence of sunlight also, it undergoes decomposition and it tries to convert into the most stable forms, which is nitrogen dioxide gas. That's why you can expect this color change, like sometimes yellowish, brownish color of changes are expected. So this is the reaction of decomposition of nitric acid. HNO3 gives rise to nitrogen dioxide plus O2 plus H2O. Reaction with bases, right? Nitric acid, it is an acid. When acids react with bases, what we can expect? Acids react with bases and forms the respective salt and water. Yes or no? Here the reactions which are given are oxides and hydroxides. So metallic oxides are basic in nature, or hydroxides anyway, they are bases according to Arrhenius theory. So nitric acid when reacts with zinc oxides, what we can expect directly? You can see zinc and here we have nitrate. So what is expected? Zinc nitrate, that's it, without any doubt, and the respective H2O. And here calcium is there, nitrate is there. What is the expected compound? Calcium nitrate. How to write the formula? Calcium valence is +2, nitrate is -1. So what is the product? CaNO3 taken twice, calcium nitrate and H2O is expected. So this is also neutralization reaction, students, double displacement reaction. When bases reacts with acids, produces the respective salts and water, H2O. Next, nitric acid reacts with carbonates and bicarbonates to liberate carbon dioxide gas. This is also very important. Not only nitric acid, acids in general, when they react with carbonates and bicarbonates, they release carbon dioxide gas. Here our component is nitric acid. Now say you identify the product, students, here. Here nitric acid is reacting with calcium carbonate. What is the product expected? Of course carbon dioxide is common in all these reactions. What is the salt expected? Calcium nitrate. See, CaNO3 taken twice. Here nitric acid is reacting with lead carbonate. What is the salt expected? Lead nitrate. Here it is again calcium nitrate. Here we have sodium nitrate, which is chili saltpeter. So, and the respective carbon dioxide gas. So here the main point to remember is when this nitric acid, when they react with what we call carbonates or bicarbonates, what is the common gas which is getting released? Carbon dioxide. What is the identification technique of carbon dioxide? When carbon dioxide, when it is treated with calcium oxide, it produces a milky color substance, milky white solution, which is calcium carbonate. It produces calcium carbonate. That's the identification technique for CO2 that you have to remember. So next, reaction with metals, like all acids react with metals and they liberate, what is a common gas? They liberate hydrogen gas. So same here, nitric acid also reacts with magnesium, produces magnesium nitrate salt. And here we have manganese nitrate salt. And what is the gas getting released? Hydrogen gas. What is the identification technique for hydrogen gas? When you keep a flame near to the hydrogen gas, it put off the fire with a pop sound, top kind of sound. Yes sir, that's the identification technique for the release of hydrogen gas. So common points you have to remember: when nitric acid reacts with carbonates, bicarbonates, release carbon dioxide gas. When it reacts with metals, it releases hydrogen gas. So here students, next, aqua regia. So here aqua regia is a famous mixture of nitric acid and sulfuric acid in the ratio of 1:3. This is high concentrated mixture where it can dissolve even gold also, students. That's how we can even extract the pure gold also, even we can purify. So most of this mixture is used in the metallurgical purposes. So whenever there is a discussion about nitric acid, definitely we have the discussion about this mixture called as aqua regia. So next we have the test for nitrates. Test means identification test. Nitrates means, students, what is nitrate? NO3 minus 1 is nitrate. If hydrogen is combined, that becomes nitric acid. If any metal is combined, that becomes the respective salt. Potassium nitrate, sodium, magnesium, all this salts we discussed in the previous slide. Yes or no? So if any salt is there, if nitric acid is present, how to identify? Salts of nitric acid are called as nitrates, like sodium nitrate, potassium nitrate, etc. Nitrates can be detected by using a brown ring test. This is a very, very famous test, students, brown ring test, where we can identify the nitrates. So freshly prepared iron sulfate, which is called as FeS4, ferrous sulfate, is mixed with suspected nitrates. So suspected means we expecting it is present, nitrate is present, nitrate salt or nitric acid in the test tube. Holding the test tube under the running water to maintain the ideal temperature conditions, concentrated H2SO4 is slowly made to slide along the walls of the test tube. In all this whole process, this is the main point. You cannot mix sulfuric acid directly. That particular color is not expected. You have to make it, the sulfuric acid slide over the test tube slowly, where it can get into the layers between this sulfuric acid and nitrate, and it forms this brown ring. I'll show you the reactions. So if nitrate salt or HNO3 is present, a brown ring of this composition, students. Brown ring is because of this, which is FeSO4.NO. Like dot means that one NO molecule is attached to this one iron sulfate, ferrous sulfate molecule. Nitroso-ferrous sulfate is the reason for that brown ring is formed between the junction of these two liquids. So look at the test. We have a sulfuric acid and we have this ferrous sulfate and nitric acid. Nitric acid HNO3, ferrous sulfate FeSO4. If you pass this sulfuric acid, sliding over means slowly getting into the walls of the test tube. So this brown ring is expected. So sulfuric acid plus nitric acid, this brown ring. What is the reason for brown ring? This FeSO4, nitroso-ferrous sulfate. Look at the reactions. If it is a sodium nitrate is there, the salt. In the presence of sulfuric acid, what is happening? It produces sodium sulfate and it generates nitric acid in this reaction. And this nitric acid decomposed to produce nitric oxide. This nitric oxide, in the presence of iron sulfate, which is ferrous sulfate, it produces this nitroso-ferrous sulfate, which is the reason for this brown ring. Got the clarity, students? This brown ring appears in between this sulfuric acid and nitric acid. So this is the identification technique for the brown ring. And uses of nitric acid. So what are the general uses we can expect from this nitric acid? Nitric acid is used in the making of dyes, drugs and perfumes. So like dyes means for coloring agents, or even for drugs means in the medicinal field also, and even the perfume. So mostly how it is used means, mostly nitric acid is used as a reagent. Reagent means whether to supply hydrogens or whether to supply oxygens, oxidizing agent, where nitric acid is best used. Nitric acid is used in the metallurgy in the form of aqua regia for purifying noble metals like gold, silver by dissolving in it. This point we already discussed. This strong mixture of sulfuric acid and nitric acid, so used to dissolve the noble metals, means unreactive metals, least reactive metals, not unreactive, least reactive metals like silver or gold. This mixture is used. Nitric acid is used in etching designs on brass or bronze articles. What are brass and bronze? They are alloys, right? Yes or no? What is etching? Etching means, students, these this nitric acid is used, it has a corrosive property, yes or no? So this nitric acid is used in order to make particular art on the metal, on the alloy. In order to make the particular art, this nitric acid is used. Why? Because this nitric acid has a corrosive nature. So because of this nitric acid, we can make any, like for example, a flower. We need to make a flower. So where there, that process is called as etching process, where nitric acid is used. So nitric acid is used in the rockets as an oxidizing agent for fuels also. It has an oxidizing nature as a student. So that's why nitric acid also used as a oxidizing agent in the rockets which are used for fuels. Why? Because rockets run on oxygen fuel, liquefied oxygen, yes or no? And nitric acid is used in the laboratories as a reagent. Like I discussed, what is a reagent? It supplies whether H plus ions or it supplies oxygen as an oxidizing agent. So all the uses nitric acid has. Nitric acid is used in the manufacturing of certain fertilizers. So main principal property of nitric acid is it has a nitrate. This nitrate is one of the essential component, essential radical for the fertilizer components. For example, sodium nitrate, like ammonium nitrate and all the magnesium nitrate. So these are all one of the fertilizers, as well as these nitrate are also used in the explosives also. So students, that's all about nitric acid, one of the key component from the nitrogen, which the nitrogen element is present. I hope you got the clarity. Thank you, students.